more students are still joining our class. Till now, only 25 students are present in our class. Okay, one by one they will join our lecture. Within a first 5 minutes, we will take a recap of our second chapter, that is the pump, accumulator, intensifier, and valves. As we discussed that pumps are the elements in which mechanical energy is converted into hydraulic energy, pressurized hydraulic energy of the fluid. Such element is called pump. These pumps are classified based on a principle of operation, displacement, and construction. In construction, we have studied the different types of the pump, its the construction, working, and application. Under the construction, pump can be classified as a gear pump, external gear pump, internal gear pump. If you are considering vane pump, constant displacement and variable displacement, vane pump. Piston pump, when you are studying, under that it will be a radial piston pump and axial piston pump. In axial piston pump, there will be split and bent axis drive that will be provided, and a screw type pump we have studied in detail. All these pumps we have studied in detail, its working, its construction, its application, right? Then we see the characteristics, performance characteristics of all these hydraulic pumps. It may consist of, we may say, positive displacement pump. We may call also rotary pumps, right? You will see the different characteristics of the pump, characteristics of centrifugal pump, gear pump, right? Now, in today's lecture, we are mainly focusing on the second part of our second chapter, that is the accumulator and intensifier. As far as concerned, last lecture we are dealing with a pump. Pump is a device which is used to convert mechanical energy into hydraulic energy or high pressure fluid energy. Whatever the pressurized fluid that will be generated by the pump, in certain application, we have to store that pressurized fluid in a certain devices, and that stored pressurized fluid can be utilized to do certain applications at a particular time, when the requirement of the application is that it require a high pressurized fluid for a certain time period. At that time, we can take and pressurized liquid from that device. Such devices are called as a accumulator. If you have seen the definition or purpose of the accumulator, accumulator is a device which is used to store the pressurized fluid which is coming from the pump. Means whatever the pressurized fluid coming out from the pump outlet, it will be stored in one device that will be called as the accumulator. And from that accumulator, that pressurized fluid, it will be supplied to the actuator at a particular time to perform certain kind of the mechanical operation. Now, what is the purpose of accumulator? Accumulator is used to store the hydraulic energy in the form of pressurized fluid. And that pressurized fluid, it will be generated because of that pressurized fluid, it will be provided by the pump. And later, provide it to the system whenever it is required or needed. Means the purpose of the accumulator is to store the hydraulic energy in the form of pressurized fluid which is coming from the pump, and you have to supply that pressurized fluid to the system when system needs certain kind of a pressurized fluid for a particular period of a time. Simply, the accumulator are the simple device that store the energy in the form of fluid under pressure. That is the definition of the accumulator. What is that? Accumulator are the devices that store the pressurized energy or hydraulic energy of the fluid. That is nothing but the accumulator. Now, where these accumulators are to be used? There are certain applications where we can use the accumulator. The first application we may call it will be a hydraulic press, where we require the accumulator. Second application in certain kind of construction equipment, farm machinery, power brake, automobile suspension, ships, and in case of aeroplane for the landing gear mechanism, we require the accumulator. These are the certain uses where we can use the accumulator. Are you understood what is accumulator? Yes, reply. Yes.
Yes, sir.
Anybody reply?
Yes, sir.
That is okay. Okay. Accumulator is a device that will store the energy in the form of a fluid under pressure, and it will supply that pressurized fluid to the actuator when it will require. Now, there are certain types of the accumulators, right? And we may say this will be the classification of the accumulator, and they can be classified based on use of energy, use for the energy storage, based on use for storage of the energy. Mainly, these accumulators are divided into three types. First one, weight loaded accumulator. Second, spring loaded accumulator. And third one, that is a gas loaded accumulator. Now, if we are considering regarding the weight loaded accumulator, these are the certain ram type accumulator, where on a ram is whatever the piston rod which is having a large diameter, so it will be act as a ram, and on that ram we are putting some dead weight, and because of that certain pressure energy it will be generated on a fluid which will be passing in a cylinder. So that accumulators are called as a weight loaded accumulator, right? We'll see in detail. In a spring loaded accumulator, where weight is replaced by the spring, the internal energy of the spring it is utilized to maintain the certain pressure, hydraulic pressure on a fluid by using the spring tension or spring compression. Such accumulators are called as spring loaded accumulator. Now, third criteria, it is a gas loaded accumulator, where in first criteria we are using a dead weight. Second, we use the spring, and in third, we are using a certain gas like a nitrogen that will be not mixed with any kind of a fluid, most of the fluids. So the gas means it is one kind of air, element of air, that is a gas, nitrogen, and that will be not mixed with the fluid, particularly certain kinds of oil in a hydraulic system. So there will be a separation between gas and fluid. Whenever we are supplying the fluid to the accumulator at that time, the gas it will be get compressed, right? And because of the compression of the gas, certain pressure it will be built up on a fluid which is supplied to the accumulator. So third type of accumulator, that is a gas loaded accumulator. Now this gas loaded accumulator are again divided into two types. First one, that is a without separator, and second one, that is a with separator. If we are considering without separator, there will be no any membrane or any we may say film membrane in between gas and the fluid or oil. So that come under the category of without separator. So it will be classified into non-separator gas-loaded accumulator, where there will be no any membrane in between gas and fluid pressurized fluid. The second criteria, that is with the separator, where we can separating the pressurized gas, that is nitrogen, and the oil. It may be hydraulic fluid, that is oil. The oil and the gas, they are separated by certain elements. In certain cases, we use the bladder. In certain cases, we use the diaphragm. Or in certain cases, we use the piston as an element to separate the oil from the air or gas. So it will become under the category of a gas loaded accumulator with a separator. That will be classified into three types: bladder type, diaphragm type, and piston type. Are you getting the classification or type of the accumulator? Yes, reply. Yes. Are you getting type of the accumulator?
Yes, sir. Yes, yes.
Okay. Okay. In a short period of a time, you can make a note of this classification. I will wait for 1 minute. Uh, are you bringing the notebook and pen for the class? You have notebook and pen with us? You? Hello? Accumulator, wet loaded, spring loaded, gas loaded. Gas loaded into two types: without separator and separator. Without separator, that is a non-separator gas loaded; separator, bladder type, diaphragm type, and piston type. Is it over? Hello? Can we move forward? Hello? Hello? Reply please.
Yes, sir.
Okay. Is it over? Okay. One by one, we will see the different types of the accumulator. The first one, that is a weight loaded accumulator, right? If you are considering, this is a diagram of a weight loaded accumulator, where this hatching section, it will show the cylinder, right? In this cylinder, there will be this piston. This portion is a piston. Now, this will be the piston rod. If you are considering the diameter of the piston rod, it is a very large. Now, why it is maintaining very large diameter of the piston rod? That is one point. And on the top of this piston rod, there will be weight, right? Dead weight, right? It may be a concrete block or steel plate, right? Like dead weight is mounted on the top of the ram. So this ram, it is loaded with the dead weight. What happen at the base of the cylinder towards the piston side? There will be one opening for the supply of a fluid from the pump to this cylinder. That is the accumulator. What happen? The fluid from the pump, hydraulic fluid from the outlet of the pump, it will be supplied to this passage. So the level of the fluid in this cylinder of the accumulator, it goes on increasing. as the fluid is entering in the cylinder, what happens? Because of the gravity, this fluid it is having a certain pressure on it because of a its dead weight and a gravity effect. Easily this piston it will be not moving in upward direction. We have to increase the pressure on a fluid so that it will lift this weight against the gravity force up to this extent when the piston reaches at this end, so that this fluid it will be passed in this accumulator. This fluid is coming out from the pump and enter into the accumulator. The level of the fluid it will be goes on increasing. How? It will act to reverse the weight of the ram, dead weight on a ram. So the pressure energy on that fluid it will be goes on increasing, so that whatever the pressure on a fluid it will be more than that of the pressure of the fluid that will be coming out from the pump. Now see here, the diameter of the ram it will be bigger. Why it is essential? We are applying weight at the top side of the piston rod. If we are putting the small diameter of the ram and length is large, diameter is small, and we are applying axial compressive load on the piston rod, at that time there will be possibility of a failure of this small diameter piston rod due to the buckling. In order to avoid the buckling failure of piston rod, the diameter of this piston rod that will be make as large as possible. A piston rod it is having a bigger diameter. So this larger piston rod and piston, that whole assembly it will be act as a ram, and on the top of this ram there will be, and that will increasing the pressure on a fluid which will be stored in this cylinder. So this total assembly is called as a weight loaded accumulator. Accumulator is nothing but certain kind of a cylinder and piston arrangement. But in order to increase the load on that fluid which is entering in accumulator, we take the help of this weight load which is put on the top of the ram. So this accumulator is called as a weight loaded accumulator. Are you getting weight loaded accumulator? Now what are its advantages? In weight loaded accumulator, the pressure remains constant for throughout the operation. Means when we are supplying that pressurized fluid to the actuator, at that time constant pressure on this fluid within the accumulator it will be remain constantly. It will be not reducing as the piston it will be moving from top to bottom side. Whatever the pressure on a fluid within the accumulator, when the piston is moving from top to bottom, it will be remain constant. That is, it will supply the constant pressure for full stroke of the piston, and it can supply large volume of fluid under high pressure. These are the two advantages of the weight loaded accumulator. Now what is the limitation of this? As we know that it is having a large size, also it is a bulky as compared to the another accumulators which are having a same capacity. So it will consume the more space, and it will require the heavy construction or structure in order to support such heavy uh, structure, in order to require certain kind of a support, right? Where these weight loaded accumulators are to be used, they are mainly used for limited applications such as stationary equipment like heavy duty presses, where large volumes are required with a high pressure. Means for a heavy duty press, hydraulic press, we require the weight loaded accumulator. Are you getting? Construction, working, advantages, limitations, and applications of weight loaded accumulator? Yes, reply. Hello, is it clear? Weight loaded accumulator. Hello, is it clear? Rohit, am I audible? Rohit, is it clear?
Yes, sir. Yes, sir. Yes, sir.
Okay. Now we'll move forward to the next type of the accumulator. That is a spring loaded accumulator. Here, spring loaded accumulator, where what change we have made in a weight loaded accumulator and a spring loaded accumulator. What difference we are observing? Where no doubt this will be the piston, and in previous figure this will be the piston rod, and on that rod there will be weight. Where the dead weight is replaced by the spring. Are you getting? Means this will be the cylinder which is having one opening at the base, and it is provided with the piston, and piston on back side it is provided with the spring, right? What happens when we are supplying the pressurized fluid from the pump to this accumulator? It will fulfill the space in accumulator. As we go on supplying the more fluid, what happens? The level of the fluid in accumulator, it will go on increasing. As level goes on increasing, what happens? This piston, it will be moved in backward direction or upward direction against this spring. Then as we go on increasing this supply of the fluid, pressurized fluid from the pump to the accumulator, this piston reaches up to this position. On upper side of this piston, there will be compression of the spring. It will be takes place. Because of that compression of the spring, what happens? The pressure on a fluid in accumulator below the piston, below the compressed piston, it will be go on increasing because of the energy stored in a spring. As this piston, it will compressing the spring. As the fluid coming out from the pump, it will be passing into the space within this accumulator. So that whatever the fluid that will be stored in accumulator, it will be get pressurized because of the tension on this spring, right? So whenever the actuator, it requires the pressurized fluid. At that time, this pressurized fluid, it will be supplied to the actuator. And because of the spring tension, the pressure on a fluid, it will be goes on increasing. So this is the spring loaded accumulator. Are you getting? Spring loaded accumulator. Here, what we are making a change, instead of a dead weight ram type provision, that will be replaced by using this spring. Now, what are the advantages? It is a compact in design. We may use more than one spring, that is multiple springs, so that the accumulator, it will be become more compact, right? And all parts are enclosed. Spring, piston, both are enclosed in a casing. So there will be no any moving part that will be present in case of a spring loaded accumulator. Now, what is the limitation of this accumulator? We cannot provide a uniform pressure. by using the spring. As the pressurized fluid it is supplied to the actuator, what happens when this piston is at uppermost position? At that time, the fluid within this accumulator it is having pressure near about 100 kilopascal, right? But when we are supplying this pressurized fluid to the actuator, what happens at that time? The level of the fluid it will be lowering. At that time, the pressure from the spring it also goes on decreasing gradually. Here we are getting the 100, here we are getting the 80, 70, 60, 50, 20. At the last, it will be near about 10 pascal, whatever the unit, right? So we cannot maintain the gradual pressure on a fluid. Those are coming out from the actuator as like in a dead weight type accumulator, which we discussed in last slide, right? Now, whatever the fluid, as pressure goes on gradually decreasing, we cannot supply the higher volume of a fluid to the actuator. So, second limitation of this spring-loaded actuator that it will supply the smaller volume of a fluid because because when the piston is moving in a downward direction, at that time whatever the energy stored in a spring it will be goes on decreasing. That will affect the pressure on a fluid. So the pressure on a fluid it will be goes on decreasing. It will result in a smaller volume of the fluid. Now where it is to be used, it would be considerably used where we require the very small space, means applications where we have a constraint on space, and also we require the small volume of the fluid at that location, at that particular application. We may use the spring loaded accumulator, right? So what is the particular then where is certain situations or particular application of a spring loaded actuator? It will be used in automotive and mobile hydraulics applications. In case of a suspension, in case of suspension provision in automobile, where the space limitation is a prime importance. And also, we require the smaller volume of the fluid for particular application. This is the construction and working of a spring loaded actuator. Are you getting? Are you getting this second type, spring loaded actuator? Any problem in spring loaded actuator? Yes, reply. Hello. Are you getting spring loaded actuator? Amol Sood. Okay. Then the next type of the actuator, that is a come under the category of a gas loaded actuator, right? In a gas loaded actuator, there are two types, without separator and with separator. And with without separator gas loaded actuator, its the example is a non separator gas loaded accumulator. See here, we were considering this one as accumulator, right? The diagram is a self-explanatory. Okay, this is a cylinder, we may say, for the accumulator, right? And on upper side, it is a charged with a gas, particularly nitrogen, right? And on a lower side, it is a filled with a gas, particularly oxygen. filled with the hydraulic fluid, right? It may be oil. We are enclosed in a steel casing, right? But there will be a less possibility of a mixing of this gas with the oil. As far as possible, we can choose the oil, the gas, in such a way that they cannot be mixed with the each other. So both are the immiscible one. So as and oil. Whatever the gas pressure exerting force on a hydraulic fluid. Right here, we are supplying the pressurized fluid from the bottom. We are supplying the charging gas from the top. And we are supplying the fluid from the pump to this accumulator, forcing in a downward direction. So whatever the fluid, it will be stored in this accumulator, hydraulic fluid stored in accumulator. It is having a certain pressure that was exerted by the gas which will be gas loaded accumulator. Means non-separator. Why it is called non-separator? Because we are not providing any other device medium in between gas and fluid. So this will be the non-separator type. Accumulator, gas loaded accumulator. Now, what is its advantage accumulator? We cannot see any kind of a mechanical element in this device. So, as no mechanical element to apply the force on hydraulic fluid, so that this construction it will be a simple one. It can absorb the shock and fluctuation as whatever the gas we are using to exert the pressure operation, because whatever the fluid when it is coming inside the accumulator, it is having a certain kind of a fluctuation, right? Pressure fluctuation that will be get normalized because whatever the gas which is present on the top side, all type of the gas, whatever the gas, it will be get absorbed by this compressible gas. So there will be no any mechanical element, so there will be no any part which have to replace after prolonged use, or there will be no any kind of a sealing arrangement is provided in this in this case. So whatever the operating cost for this advantages of this non-separated type gas loaded accumulator. First one, that is a no mechanical element, so simple in a construction. It can absorb the shocks or fluctuations because whatever the gas we are using in this type of accumulator, it is a compressible one and no moving element. Now, what is the limitation of this such type of the accumulator? That is a due to the absence of the physical separator between gas and the fluid. The gas may get absorbed. by the oil in certain time. So it will make the oil compressible. Gas, it will be get absorbed by the oil. As in this type of the accumulator, we are not having any kind of a physical separator in between gas and accumulator. In certain cases, sometimes that gas it will be absorbed by this oil. Because of that, the oil compressible leading to compressibility nature of the oil, the jerky motion or certain kind of fluctuations or jerk, it will be happen while operating the actuators by certain oil. Second limitation for this type of actuator
रजवा सर आउट झाले.
हा आउट झालेत, बाहेर पडलेत. आवाज येत होता का सरांचा नीट?
येत नाही ना, क्लिअर येत नाही आवाज.
मध्ये मध्ये कटच होते पूर्ण आवाज.
पूर्ण कट होतं.
सचिन सरांना फोन लावला काल?
काय झालं?
सर लेफ्ट झालीत मीटिंग.
एक मिनिट.
दुसरी लिंक शेअर करायला सर ग्रुपवर लिहू आहे मी.
हॅलो.
हाँ सर.
Okay, okay. Same link, another link. How you are getting it? Okay, in are you listen? Are you are you getting this non-separated type gas loaded?
Sir, your voice is not audible.
Okay, okay. Now, is it audible? Is the screen is visible or not?
Yes sir, visible.
Hello, may I audible or not? Okay, screen is visible and may I audible too, right? Hello, hello.
Yes, sir, we can hear you.
Is it visible? Okay. Hello. Listen, description will is non-separated accumulator. It is a with a separator. Means we have to separate out the gas and the hydraulic fluid by certain kind of a physical member that is called as a separator. First type, that is the bladder type accumulator. If you are, this is the bladder. See, it is of a certain kind of a, this is a certain kind of a elastic member, elastic separator or membrane that will separate out this hydraulic fluid, and this will be the gas. And in this bladder, it is one kind, it is filled with a gas on this top side. This will be the certain kind of the cap or locking arrangement. It will be called as a protective cap, and this will be the, hello, हा सुरू झाली की हो डबल चालू झाली की एकदा बघ वर तू जॉईन करून नाही ना पहिल्याच ह्याला माझ्यामध्ये जॉईन झालेलं sorry, and this is the bladder. It is filled with the gas, nitrogen, particularly nitrogen gas under pressure, right? And we are supplying the hydraulic fluid from the pump at this bottom side, and this is the oil valve assembly. Hello. 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 Hello.
हाँ सर.
Hello. Am I audible? Mangesh?
Yes,
Okay.
sir.
Certain problem related to the network I'm facing. So that uh, because of the coverage problem, the link it will be get disturbed or disconnected. Right? Okay. Will on this bladder type accumulator. In bladder type accumulator, this will be the elastic membrane that will separate out from oil and gas. So with the pressurized fluid, it will be act as the elastic separator between oil and gas. What happens when we are supplying the fluid from the pump? It will be passing this oil wall assembly, and it will fill in the space and pushing this bladder in upward side. But this bladder is filled with the pressurized gas. So against that pressure, we are supplying the fluid in this accumulator so that whatever the fluid that will be present in this accumulator, it is under pressure because of that gas, this bladder that will exerting the pressure on fluid which is coming out from the pump and passing into the space of this accumulator. Whenever we have to supply this fluid, pressurized fluid to the actuator, at that time the fluid it will be passing to the actuator. This bladder it will be get on expanding. Initially it will be get compressed when we are supplying the fluid from the pump. It will be get compressed, and because of the compression of that pressurized gas, this bladder it will be imparting certain pressure on a fluid. But when we are supplying this pressurized fluid to the actuator, at that time this bladder it will be get expand, and whatever the gas which will present in a bladder, its pressure goes on increasing because the area for the expansion goes on increasing. So it will not providing a constant pressure on a fluid when that fluid is passing to the actuator. At the same time, it will supplying the low volume of a fluid under low pressure to the actuator. We will see different position of the bladder working of this bladder type accumulator. The first position, that is the normal position where the bladder is completely expanded, having a pressure P0 and volume P0. Then we are supplying the fluid here. This bladder is completely expanded. Right? We are uh, filling this bladder with the gas, nitrogen gas. Right? So it will be get expanded completely within this accumulator. This wall, it is in a closed position. When we are supplying pressurized fluid from the pump, what happens? This wall, it will be get lifted, and that pressurized fluid, it will be entered in accumulator space. As pressure goes on increasing, as it will be passing into the accumulator, the pressure of the fluid, it will go on increasing. It forcing this bladder from this original position to this position. Whatever the gas within this bladder, it will be get compressed. Because of that, the shape of the bladder in compressible form, it will have compression. The pressure and volume within this bladder, it will be changing from P0 to P2 and P0 to here. When this accumulator, it will be get at time, the pressure of the gas within the accumulator, it is the maximum pressure, that is a P2, and the available volume of the fluid, that is the delta P1 minus P2. Before that, we have to know that what is the V1, right? Now, when we are supplying that pressurized fluid to the actuator, at that time what happens? The fluid, it will be coming out from this wall and pass to the actuator, and this bladder, it will try to get expand. So this is third position where fluid from the accumulator to actuator is going to pass. At that time, bladder is going to expand. So by after expansion, its pressure reaches to P1 and volume reaches to P1. So from this diagram, we are able to know that how this bladder type accumulators are going to operate. Here, accumulator when discharged, whatever in this accumulator, it will be supplied to the actuator. P1 minimum working pressure. So P1 is a minimum working pressure denoted by P1. Here, at the initial state, this bladder cover the entire inner volume of this accumulator. Then we supply the fluid from the pump to the accumulator. At that time, accumulator gets, the bladder gets compressed because of this fluid. So this fluid is gets pressurized. And when this pressurized fluid, it is supplied to the accumulator, this actuator, at that time this accumulator gets discharged. At that time, bladder gets expanded and the P1 pressure in a bladder. In this way, this bladder type accumulator, it will work. Now, what are the advantages? Advantages of accumulator, this bladder type accumulator. It provides positive sealing gas and oil chamber because it will present between oil and the sealing of oil and gas. It will be a positive seal. Second, it is compact and light. There is a so it has a small inertia and it provides quick pressure response. Even a small minute change can happen in a pressure of the gas. As far as possible, this bladder is a rubber element and it is having certain inertia. Any change in pressure or volume, it will affect the operation of this accumulator. As it is having the less functional part, it is a less expensive, less expensive, right? These are the advantages of the bladder type accumulator. Now, what is the limitation? The pressure exerted on a fluid is not constant and goes on reducing as bladder goes on expanding. As we see in the previous certain types of the accumulators, in only RAM type or deadweight type accumulator, we are providing constant pressure with a higher volume. Remaining all the accumulators, they are not providing constant pressure, right? And the volume to the actuator, it goes on decreasing, right? So less volume, relatively smaller volumes are provided by such kind of the actuator. Bladder is one kind of a rubber element. So after prolonged use, it is necessary to replace it, or certain kind of service it will be required. In certain kind of the accumulators. Such type of it is having a certain kind of a melting point, right? So there will be limitations for handling high temperature fluid by using bladder type accumulators. Now, where it is used in the suspension system of the automobile vehicle, it is used bladder type accumulator is used in a suspension system or wheel suspension system of a automobile is required. At that particular application, we can use the bladder type accumulator. Are you getting bladder type accumulator? Yes. Yes, bladder type accumulator. Are you getting? Please reply.
Yes, sir.
Bladder type accumulator. Okay. Prajakta Surve, are you there? Prajakta, Shraddha,
Yes, sir.
Shraddha. Which type of accumulator
Sir, your voice is stucking.
we have studied now? What is the type of accumulator? Reply, Shraddha.
Bladder
Huh?
type.
Which accumulator we have studied now? Which? Sorry, diaphragm type or bladder type?
Bladder type, sir.
Hello. Reply, Shreyesh. Okay, bladder type. Now, where is the application of bladder type accumulator? Application. Yes, anybody? Saurabh. One is there. Saurabh, where is the application of bladder type accumulator? Saurabh, reply please. Yes. Yes, Gadikar is there.
Yes, sir.
Hello.
Yes, sir.
What is the application of bladder type? Application. Application of bladder type accumulator. Hello. Can you tell me the application? Are you listen or not? Yes. Only you are enrolling the lecture.
Sir,
Yes, sir. Hello. Sir, your voice is breaking.
sir, while teaching, your voice was not completely audible. It was coming and going.
Not listening carefully. Hello.
And
Sir,
now
your
also,
voice
sir.
is
And now also, we can't
Ah,
hear you continuously.
okay, okay. Consistently, it is not. Ah, okay, okay, okay. That is the problem you are facing. Okay, okay. Understood this bladder type accumulator, working of bladder type accumulator. Yes, reply. Hello. This piston type. Hello. Is it visible or not? Hello.
Yes, sir, it's visible.
Piston type gas accumulator. Okay, okay, okay. There will be another type of the. This will be the. There is a piston, and from the top side we are supplying the gas, and that gas is exerting the pressure on a top surface of the piston, and at the bottom portion coming from the pump, it will be enter into the cylinder. At that time, whatever the gas coming out from the top, it will exerting the pressure on upper side of the piston, right? So whatever the fluid in this accumulator, it's under pressure. As level of the fluid goes on increasing, this gas it will exerting the pressure on the piston. Then we are supplying this pressurized fluid to the actuator. The pressure goes on decreasing on a fluid. At the same time, the volume of the fluid to the actuator it also goes on decreasing. This is the piston type gas separator accumulator. Right? Gas charge accumulator, piston working. Are you getting? This is one cylinder. It is filled with piston, having a piston, and top side another one cylinder assembly is there. But on a peripheral of the
Sir, we can't hear
this
you.
internal cylinder, it is filled with a gas coming from the outside, and the bottom side of the of a Hello, Prajwal.
Sir, many disturbances coming while you are talking, and we are not understanding what you are teaching exactly.
Whether my voice is
Sorry, sir, we
not
can't hear you anything.
audible, or it will be not continuously coming to you.
Sir, exactly what you're speaking, that only we are not getting because the voice is not continuous. It's coming and going in between.
Now I'm using the headphone. Now, is it audible?
Sir, now it's audible, but
Hello. Huh. You unmute yourself and talk with me.
sir,
Now,
yes,
is it
sir, it's
audible?
audible.
Uh, is it sticking
No, sir,
or
now
not?
it's not.
Now, clearly
Yes, yes,
audible,
sir.
right? Okay. And now, see, uh, is it visible, Prajwal?
Yes, sir, screen is visible.
Okay. Now, this is a piston type gas loaded accumulator, right? If you are considering its construction, there are two cylinders. This one is the inner cylinder, which is provided with a piston, and another cylinder, it will including this inner cylinder, right? What provision over here? There will be no passage for the gas to enter into the inner cylinder from bottom side. There will be one single passage for the fluid that will allow the fluid coming out from the pump. It will enter into the inner cylinder only at the bottom side of the piston. And from the top side of the piston, we are supplying the gas, right? Pressurizer gas. And it will occupy the outer surface of the cylinder, outer peripheral surface of this cylinder. Then it will fulfill the inner space of this inner cylinder on a upper side of this piston. What happens when we are supplying the fluid from the pump to this accumulator? It will fill this space, and the level of the fluid it will be goes on increasing. But at the same time, on the other side of the piston, whatever the gas we are supplying, it will exerting the pressure on downward side on this piston top surface. So when the level of the fluid in an accumulator goes on increasing, the gas it will be goes on compression. So pressure it will be exerted on this fluid which is coming from the pump. Whenever you are supplying this pressurized fluid to the actuator, what happens? The pressure it will be goes on decreasing as the piston is moving from top to upper side to lower side, because the expansion of the gases it will be takes place, and because of the expansion of the gases, the pressure on a gas it will goes on decreasing. So at the outlet we are not getting the constant pressure on a fluid. The pressure on a fluid it goes on decreasing as piston is moving from upward side to downward side, and at the same time we are getting a low discharge of the fluid from the accumulator to the actuator. Is it audible now, visual?
Yes, sir.
Okay. Now what are the advantages of this piston type gas charge accumulator? It can handle the fluid which is having the high temperature as well as low temperature, because in case of a bladder or diaphragm type actuator, this bladder or diaphragm, these are the certain kinds of the elastic separators, and majority they are made up from rubber, and rubber cannot withstand with a high temperature fluid. But in case of a piston type gas charge accumulator, the piston cannot affect its performance because of a high or low temperature of the fluid. So such a type of the accumulator can handle high or low temperature fluid. It can mounted in any position. It is not necessary to fit in a vertical position as like a bladder or a diaphragm type or a bladder type accumulator, right? The piston provides a certain positive seal between gas and oil, because certain seal, piston ring and V-type seals, these are the seals of piston rings. They can provide the positive seal between this gas and the fluid. It acts as one kind of a sealing element. Its working life is longer as compared to the bladder type, because bladder it is made up from rubber. Now, what are the limitations of this piston type gas charge accumulator? Such type of the accumulator are expensive to the manufacturer, because all our parts are the metal parts, and which will require the high precision. The pressure is a function of compression of the gas, and it will vary with the volume of oil in a chamber. This is one of the limitations of this piston type gas charge accumulator. Now, where it is to be used? Due to expensive in nature, its application is limited to high temperature system with a smaller volume requirement. Means piston type gas accumulator, those are used in a system where high pressure hydraulic fluid is to be used, and the requirement of this system it is related to the smaller volume. Means smaller volume and high temperature requirement is there. At that location, we can use the piston type gas accumulator. Is it clear? Piston type gas charge accumulator, its construction, working, advantages, limitations, and application. Just we have discussed. Yes, reply anybody? Is it clear?
Yes, sir.
Yes, sir.
Okay. Now there are certain applications of accumulators, right? But you may see accumulator as a secondary source of energy. Here, this is the cylinder and piston arrangement, right? Here we are using a different kind of symbols for different elements. Just I will give the brief of the working as a its a application. That is accumulator as a secondary source of this is the direction control valve. This is the solenoid pressure, speed, and volume control valve.
Hello?
Hello. Network problem, because of that connection may get lost. That always I am suffering from this problem. Is the screen is visible?
No.
Now is it visible?
Yes, sir.
Okay. We are discussing about the certain applications of the accumulator. In this diagram, or in this circuit, hydraulic circuit, we are dealing with this accumulator. It will be act as a secondary source of energy. Means whenever the uh, we are supplying the pressurized fluid from the pump to the left hand side of this piston. At that time, piston is moving in a right hand side. It will doing certain kind of operation. But on a reverse position, we have to fastly moving this piston towards the left hand side. At that time, we have to press this solenoid valve. So this position come under the actuation. At that time, whatever the fluid supplied from this actuator, it will be passing through this line to the right hand side of the piston. So this piston, it will be moving on left hand side with a fast action. So certain fast movement of the piston from right to left whenever it is to be desired at that time for that particular short period of time, surplus supply from the actuator of high pressurized fluid, it will be used by using this second position, so that the pump is able to supply a limited pressure on a fluid to move the piston from left to right. But whenever you have to move this piston from right to left with high speed, at that time we can take the help of the pressurized fluid in an accumulator, and that will be actuated by using the second position. And the second position, it come in action by using this solenoid control valve. What happen? The pump is supplying 10 pascal pressure, and this piston is moving from left to right. But when you have to move this piston from right to left with a very high speed, we require the 15 pascal pressure. At that time, pump is limited for 10. We require more 5 pascal, and that 5 pascal it is supplied by using this accumulator. And certain pressurized fluid from pump, then from accumulator, then this position comes, this arrow, it will touches this line. So 15 pascal pressurized fluid, it will be supplied from right hand side of the piston. So this piston, it will be moving towards the left with a certain high velocity. So that this accumulator, it will be act as a secondary source of energy. Is it audible? Hello? Hello?
Yes, sir.
Okay. Likewise, the second application of the accumulator. We see this is a clamping of the workpiece from left hand side and from the top. We can clamp this workpiece in this work holding station, right? For that purpose, we use the accumulator. Here we are using the pump, fixed displacement pump. It's the pressure reducing valve. These are the certain kind of the direction control valve. When we are supplying the pressurized fluid by using the pump through the direction control to the left side, it will move the piston toward the right, so that this device, it will be moved in right hand direction, right? But it must be in a same firm position, this piston it will be at this location. For that purpose, now linear motion it will be controlled by using horizontal motion it will be controlled by using this cylinder piston arrangement. But vertical motion it will be controlled by this cylinder piston arrangement. For that purpose, what we have to do? We are diverting this flow instead of through this direction control valve to this piston cylinder arrangement. For the horizontal displacement, we are diverting this flow to this direction control valve, so that this piston it will be moved in a downward direction. So the vertical clamping is feasible. At the same time, we must have to maintain constant pressure by using this piston cylinder arrangement for the horizontal fixing of this object. For that purpose, we are providing this accumulator over here. As we are diverting this flow of the pump for the vertical clamping of the workpiece by using this cylinder piston arrangement. At the same time, we are maintaining a certain pressure on this workpiece by using this cylinder piston arrangement and by supplying pressurized fluid from this accumulator to the left side of this piston. We are not passing this fluid from pump to this direction control valve to this cylinder piston arrangement. We are now diverting the flow in this direction. So vertical clamping is over here, and previously we are carried out but horizontal clamping. But when we are diverting the flow to the cylinder, at that time the horizontal clamping pressure it will be maintained constant by using this accumulator. This is the second application where we can use the accumulator to maintain the constant pressure. Are you getting this second application? Hello? Are you getting? Accumulator is used to maintain constant
Yes, sir.
pressure. Okay. Now third one, that is how accumulator is used as a makeup device. Here, this is the one cylinder piston arrangement. If you are considering both the area on either side of the piston, on left hand, on a downward side, we are having a large area. On upper side, we are having less area because it will consist of this piston part. When we are supplying the pressure, we are applying the force on this piston rod, what happens? The piston it will be moving in downward direction. At that time, whatever the fluid which is present on the lower side of the piston, it will be passing through this flow control valve or pressure control valve, right? So this fluid is having a volume V1. Now it is passing to the upper side of the piston, but the volume V2 it is less as compared to the V1 because this particular space its volume minus, we have to minus the volume of the piston rod. So if we are considering this one is a V1, this one is a V2, and this one is a V3, then actual volume at this section, that is a V2 minus V3, which is less than V1. At that time, whatever the liquid or fluid displaced from this volume V1, it cannot be accumulated by this volume, that is a V2 minus V3. Certain amount of the fluid it will remain unoccupied. That will be get stored in a accumulator. Suppose this is a volume 15. 50 meter cube volume is there, and we are also it is a 15 meter cube, but the volume it is reduced by this piston rod up to a 5 meter cube. So the upper side of the piston it is having a volume of a 10 meter cube, and lower side it is a 15 meter cube. There will be difference of a 5 meter cube of volume. As the piston moves in downward side, we are getting 15 meter cube of a volume. It will be reaching to the upper side, but no space is available to accommodate 5 meter cube of a volume. That surplus 5 meter cube of volume, it will be get stored in a accumulator. When this force is released, what happens? This reverse flow of the fluid, it will be takes place. At that time, 10 meter cube of fluid, it will be coming from this side. It will occupy this space. Again, 5 meter cube, it will be remaining to fill up that required 5 meter cube of volume. It will be taken up from the accumulator. So this total 15 meter cube of volume, it will be occupied. So this is a certain case of example as accumulator used as a fluid makeup device. If extra fluid is displaced, it will be stored in accumulator. If extra fluid is required, it will be supplied from the accumulator to the system. So this is the another use of accumulator, which is used as a makeup device. Are you understood? Accumulator as a makeup device? Please reply. Yes.
Yes, sir.
Now, second use of an accumulator in case of a wheel suspension system of atom coil, that is a hydro-pneumatic wheel suspension. This will be the accumulator. This will be the pump, pressure reducing valve, the reservoir. This is a check valve, one-way valve. It will allow the flow in only one direction. And this is the direction control, right? Infinite direction control. This is the fixed position. Always we are not getting the road. It is a flat surface. It is having a flat surface. There will be a certain texture. Because of that, this wheel, it will be move upward and downward, right? Because the different condition on the road, it will move this wheel upward and down or jumping condition. At that time, this is the cylinder. It will be providing the flow from the pump. And these are the certain positions of the direction controller, which will supply the fluid from the pump to this, we may say, hydraulic cylinder, which will neutralize the jumping, because of the jumping motion of the pump, jumping motion of the wheel. Certain pressure fluctuations are coming in the cylinder that will be absorbed by this suspension cylinder, so that whatever the upper part above the suspension cylinder, that is the body of the vehicle in which the passengers are sitting, they are not suffering from the jerk because of the irregular condition of the road or not a flat condition of the road. As vehicle is moving on the road and it is passing over the speed breaker, at that time the wheel, it will be get jammed, and whatever the jerking action because of the wheel, it will be produced, that will be neutralized by this suspension cylinder, and we are not getting any kind of a jerk who is traveling through this car as a passenger. This is a hydro pneumatic wheel suspension system where we can use the accumulator. Now, when accumulator is to be used, in order to compensate the jerking of the fluid, at that time extra fluid is required, that will be supplied by this accumulator. Are you getting? Accumulator as a used as a in a wheel suspension system? Yes. Reply please. In wheel suspension system, we can use the accumulator to absorb the shock. Yes, reply please. Hello. Am I audible? Pritam. Hello. My voice is audible or not? Prajwal, please reply.
Yes, sir.
Sir.
Okay. The next part, that is the intensifier. Right. Now, intensifier. These are the devices being called as a pressure boosting devices. A pressure intensifier is a device that is used to increase the pressure in a hydraulic circuit to a higher value than that of the provided by the pump. Means in certain hydraulic systems, the requirement of the hydraulic energy or the pressure of the fluid, it will be more, and that cannot be achieved by using the pump. At that time, in order to increase the pressure on that fluid, we use the certain pressure intensifying devices called as a intensifier. Means intensifier is a device that is used to increase the pressure in hydraulic circuit to a value that is a greater than the pressure developed by the pump. Intensifier can take high volume, low pressure flow from the pump. Means whatever the fluid it is supplied to the intensifier, it is coming from the pump, and pump it will be supplying high volume. Volume is high, pressure is low. Such kind of a fluid it is supplied by the pump to the intensifier, and that intensifier it will convert the portion of this flow to a required value of a high pressure. Whatever the fluid supplied by the pump, that is a high volume, low pressure, that will be converted, some portion of that flow, it will be converted into high pressure by using this intensifier. Are you getting intensifier? In simply, we have told that intensifier is a device which will use to increase the pressure on hydraulic fluid, which is not possible to increase by using the pump. Means pump is having a certain limitation up to which it will increase the pressure. But whenever it is required to have pressure of the fluid more than the pressure produced by the pump, at that time we use the intensifier. Here, this is a simple block diagram which you use the intensifier. It will show the principle of the intensifier. This is the cylinder, this is the piston, this one, and this is the piston rod. The piston rod again moving through this portion, it is one another cylinder. Now what happens? We are supplying a low pressure fluid with a high volume on the left hand side of this intensifier. It is having the area, piston area. On this side, it is A1, and the pressure of the fluid on the larger side, it is P1. The pressure is low, but volume is high. Then we are supplying this low pressure and high volume fluid. It will move this piston toward the right side. Whatever the fluid which is present in this region, the area of piston it is less, and the pressure at this portion it is P2. As this piston moving toward this right, at that time what happens? Area gets reducing, but pressure gets increasing. Yes. Amplification of the pressure it will be take place because of a reduction in a area. So pressure it will be goes on increasing. This is the working principle of the intensifier. Whatever the fluid on the right hand side, it will be its pressure goes on increasing. See, there are 2 to 3 types of the intensifier: single acting, double acting, right? These are the types of the intensifier. This is a single acting type, intensifier, where this is the piston, this is a cylinder which is having a very large area, and this chamber is called as a low pressure chamber. Whatever the fluid coming from the pump, it will be passing over here, right? And this is the another chamber, right? It is called as a high pressure chamber, and it is a supply with a certain fluid, right? Check valve is provided. When low pressure, high volume fluid from the pump, it is entering in this low pressure chamber, it will pushing this piston towards the right hand side. At that time, whatever the fluid which is present in this chamber, which is having a low area, right? And now this movement of the piston toward the right hand side, it will increasing the pressure on the fluid which is present in this chamber. So we are getting the high pressure fluid from this outlet of the high pressure chamber. So this is the symbol of a single acting system. We are supplying low pressure, high volume fluid from the pump. This is the piston. Another end of the piston rod, there will be another piston and cylinder. Here we are getting the outlet to the circuit, and this low pressure, high volume fluid, it will moving this piston toward the right and supplying the high pressure fluid at the outlet to the circuit. This is the single acting intensifier. Are you getting single acting intensifier? Hello? Hello?
Yes, sir.
Okay. Now double acting intensifier. What change we have made? In double acting intensifier, on one side and one end of piston we are providing piston rod and this cylinder arrangement. In single acting, where on both sides of the piston we are providing the piston rod and the cylinder arrangement. So whenever we are supplying this low pressure fluid on this side, at that time this piston it will be moving towards the right hand side, and we are getting high pressurized fluid at this location. When you are supplying low pressure fluid from this side, at that time this piston, central piston, it will be moving toward the left hand side, and this cylinder piston arrangement, it will supply the high pressure fluid on the left hand side. Means in double acting intensifier, we are having the two separate openings for the supply of a low pressure fluid from the pump to the intensifier, right, on either side of the piston. And this piston, it is symmetrical from the vertical axis, and it will supply constant pressure on either side of the piston to this outlet. This is the double acting intensifier. Now third one, that is the air oil intensifier, right? Air oil intensifier means it is like a double acting cylinder, but what change we have made? In a larger volume, we are supplying the gas or air. Here, this arrow, it is a blank one. So it is an indication of a pneumatic. Pneumatic means gas or air we are supplying. And in this cylinder piston arrangement, see this arrow. This is a filled arrow. It is the indication of hydraulic, that is oil. Means one side of the piston, it is provided with the pressurized air. It is a low pressure and high volume air will pass to the cylinder. It will pushing this piston toward the right. This piston toward the right. And due to movement of this piston toward the right, the smaller piston, it will be moved in a forward direction. At that time, whatever the fluid which will be present in this space, high pressure side, the pressure on this fluid, that is the oil, it will be get increased, and we are supplying the high pressure oil to the circuit. Means air oil intensifier is as like a double acting intensifier, but here on one side of the piston we are supplying the pressurized air or gas, and on another side we are getting the high pressure oil from the outlet of that intensifier. This is the air oil intensifier. Are you getting this? Air oil intensifier. Only change is that
Yes, sir.
air and oil both are used in such case of the intensifier. Okay, I think this intensifier that part is over. So in today's lecture, if you are considering from the start, we are studying the accumulator. Accumulator is a storage device which will store the hydraulic energy in the form of pressurized fluid. Its classification we have seen: dead weight, spring, non-separator, bladder, piston type. One another type is that diaphragm. Diaphragm is like a bladder type. Only one membrane is there. It will separate out this gas and fluid. Then we see different applications where we are using the accumulator as a secondary source of energy to maintain constant pressure, to make up as a makeup device, as a suspension system. Then we see the intensifier. Intensifier are the devices, those are used to increase the pressure in a hydraulic circuit greater than the pressure exerted by the pump. We see the principle of intensifier, certain types of the intensifier, that is single acting intensifier, double acting intensifier, and air oil intensifier. I think this is sufficient for this today's lecture, right? Are you understood? Yes, reply. Are you understood? What is accumulator?
Yes,
What is
yes,
the
sir.
intensifier? So tell me what is accumulator? Anybody can define the accumulator? What is accumulator? Yes. Anybody? Saurabh Sawan, what is accumulator? Hello? Nobody can define the accumulator?
Sir,
Huh.
hello. Sir,
What is
accumulator is a device which convert low pressure, high volume fluid to the high pressure, low volume. Or it
accumulator?
it is a device which convert high volume, low pressure fluid to a certain value which is higher than pump.
Uh, Accumulator is a device which will store the
Collect,
pressure.
store the oil under high pressure and release the high pressure oil to the system when needed.
Right, right. That is the accumulator. And whatever who is telling this one, that is a function of intensifier. Somebody is telling, right? That is a Hirshaw Rai, which is telling the function of intensifier. Now,
Yes, sir.
what
Yes, sir. Intensifier. Sorry, sir.
is the intensifier, right? What are the different types of the intensifier?
Single acting, double acting, air, oil.
Air oil intensifier, right? Anybody can classify the accumulators?
Dead weight type,
Accumulators.
spring loaded type, air or gas loaded accumulator.
I think this is sufficient from this lecture. Uh, right. We will take attendance. Okay. Can you tell me the present numbers? So remaining will be considered as absent. Right. Hello. Hello. Okay, one by one, I will ask Azam Sheikh. What is the roll number? Azam Sheikh.
53, sir.
A or B?
A division.
A. A 63. Huh? Then Akash Mane. Akash Mane.
B division 70, sir.
So
70.
17.
70.
Okay. 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 Atish Dado.
A
Atish.
division 13. A
Yeah.
division 13.
Okay. Okay. Deep Jyoti. Tate.
A division 8.
Okay. Uh, Harisho Rai.
Sir, B division 39.
Okay. Good. Kiran. Kiran. Kiran is present.
A division 33.
Okay. Good. Komal. Komal is present. Then Mangesh. Mangesh Mishra. Hello.
A
Mangesh.
division 44.
A division. Okay. Milind Dagdale. Milind.
A division 34.
A, na?
34 A division.
Okay. Nikhil. Roll number.
47. A division.
Hello.
A division 47.
Okay. Okay. Nilesh.
B division 21.
Okay. Good. Paras Mule.
Sir, A division 58.
Okay. Prajakta Surve.
B division roll number 8.
Okay. Good. Prajwal.
A division 55U.
Pratik.
B division 1414.
Okay. Praveen.
A division 65.
Okay. Pritam. Pritam. Rutik.
A division 31.
प्रीतम आहे का प्रीतम सचिन सचिन वाघमारे
A division 49.
सौरभ
A division 16 16
61 का 16
16
श्रद्धा
A division 2 number.
श्रेयस श्रेयस चौहान
A division 17, sir.
ओके विनायक बापट
B division 11 number.
okay anybody is missing anybody is remaining okay thank you very much we will see you on next lecture